All right. Thank you, Jose. Good afternoon, everybody. I'm pleased to have the opportunity to visit with you today. The topic that I've been given is a challenging one, and I struggled my way through it. So hopefully I've ended up with a reasonable product. We'll see as we go along. I'll begin just by giving you a little bit of context, and let's see. Let's try this. There we go. So first, I want to just give you some sense of Florida forage systems and where we might plug legumes into those systems, all right? So we begin by basing our systems on warm season perennial grasses. That's a given. Some of those grasses might provide us some fall forage for stockpiling. We have small grains that we can plant during the fall and utilize for winter and spring grazing. But then we have the cool season forages, and this is really the first instance where the legumes come into play. So clovers are a significant part of our system during this time of the year. We've got some potential warm season annual grasses, and then we add the warm season legumes from spring through fall. So basically, we're looking at two primary periods during the cool season and then during the summer into fall, when we can easily plug legumes into these systems. All right, so this is what I'm going to try to do. I'm going to give you a little bit of a historical perspective on use of legumes, and I'm going to focus on warm climates, talk about some specific challenges, try to address the question of why bother with legumes. Most of my time will be spent on this fourth point, primary forage legumes adopted in Florida, why they work or sometimes don't, and then a little bit of a look into the future. All right, so let's start with a little bit of history. And many of you don't know me, but I grew up on a dairy farm in South Central Pennsylvania. Within the temperate context, we don't necessarily talk about legume adoption because everybody's using legumes, okay? It's not a surprise, it's not unusual, it's not a big deal. Everybody's got them. They're a core of the system. Within a warm climate context, however, it's a different reality. We have observed as people all over the world working in warm climates that there's a challenge or a greater challenge associated with getting legumes into warm climate grass-based systems. One of those challenges relates to legume persistence. We have simply not been as successful in many cases in finding legumes that are long-lived, persistent contributors to our system. Another is simply that the grasses that we traditionally use, the Bahayas, the Bermudas of the world, are generally pretty easy to manage. They're not so demanding. They respond to nitrogen fertilizer. They're predictable, relatively low risk, and historically at least profitable. Okay. So within the warm climate context, that's the scenario we've been working with for some time. Now, I'm not going to do to you like I do to my undergraduate students, like the ones I was teaching this morning, where we go into a lot of detail, but I just want to raise a couple of specific challenges to you relative to the use of legumes. So it turns out that legumes actually are put together differently than our warm climate grasses. Their physiology is very different. We don't need to know the details of that, but what we do need to understand is that physiology contributes to grasses typically being better adapted to high temperature environments and the kinds of climates that we experience in places like Florida. Grasses typically will out-yield legumes if nitrogen is not limited. interesting thing to me is the point of origin of these different groups of plants. The warm climate grasses that we use in Florida, typically, or many of them came from Africa. And within that context, they were exposed to conditions of grazing and treading by large herbivores for long, long periods of time, right? Those grasses have the benefit over legumes, most of which came from the tropical Americas, where the introduction of large herbivores in timescales at least is recent. And so those grasses had much more time to develop the ability to tolerate the kinds of pressure that we put them under in grazing systems. All right, so we've learned that historically, warm climate have not necessarily been all that favorable for legumes. We've talked about some of the specific reasons why that may be the case. Now let's try to address this question briefly of why bother with legumes. One that we always come to is the ability of the legume to take nitrogen that is inaccessible to the plant in any other way out of the atmosphere and fix it in a form that the plant can use. And in so doing, then we can reduce or replace nitrogen fertilizer, which last time I checked was not cheap. Legumes definitely, without a doubt, can produce higher quality forage and greater animal gains than grasses. That's not in dispute. That's not my opinion. That's documented hardcore fact, all right? More recently, we've looked at some of the contributions of legumes more from an environmental perspective or an ecosystem services perspective, and found that they can reduce greenhouse gas emissions. And as Dr. Dubé will talk about a little later today, they can increase soil nutrient cycling. So this is a small list. I'm not going to go through all of it because that's not really the purpose of the talk, but these are some of the reasons why we continue to find legumes very attractive in forage systems. All right, now we're going to transition to some of the actual legume species and talk about them. So you may have some other legumes that you'd like to put on the list, but here's a list of candidates for use within the general Florida context. I've chosen a few of these to focus on. So we're going to focus on Aeschynomene, Alfalfa, the clovers, and Rhizoma peanut. So the way we're going to do this is I'm basically going to just give you a quick snapshot of these plants in a production setting. And then, as you can see here, I'm going to ask them questions about the adoption or the use of these legumes. So we'll start with Aeschynomene. If you're not familiar with Aeschynomene, it is primarily used for grazing. You typically would find it more in South Florida than in North Florida because it is very well adapted to wet soils. And it is generally overseeded into perennial grasses, not typically used for hay production because it develops a fairly woody stem. All right, so what are the questions we want to think about? With any plant, we want to know whether it can be reliably established. So we'll talk about establishment. It's an annual. So as an annual, if it's going to be back next year, it either needs to plant itself or we need to plant. All right. And so can it naturally reseed? In other words, can it plant itself? And then lastly, what does it do to animal performance? All right. So relative to the establishment question, I'm going to take you through, looks like we've lost a little bit of the top part of the screen, but that's okay. I can introduce that to you. I'm just going to take you a little bit of show and tell here. All right. So a number of years ago, we had a limpo grass pasture that we burned in the spring, and we were going to establish Aeschynomene into this pasture. So this particular picture is 7 weeks after a burn of limpo grass, right? Picture's probably taken about the end of May. It was at this point then we were getting ready to plant some Aeschynomene. And so what we did was we brought cattle in, and one thing we're concerned about when we're planting a warm season legume like Aeschynomene into a warm season grass is that we've got to control grass competition. because we're starting out by just putting a seed into the system in terms of the legume, and we've got an actively growing grass in its prime time, all right? So we graze that grass really hard, which is basically what you see here, and then we planted the legume. So you can see here, I think beside the pen, you can see some Aeschynomene seedlings that are establishing in that grass. One of the things we're interested in then is how long after we plant this legume and it begins to grow, which you can see here, do we need to continue to control grass competition? And the way we were doing that was by grazing. So in this case, we did it for just 1 week after planting. At this point, we started to see the legume seedlings, pulled the cattle off, and allowed that legume to grow and develop so that it'd be ready for subsequent grazing. On the other side, we continued to graze for 4 weeks after planting. I don't know to what degree you can see it, but there is quite a bit of Aeschynomene here that is now at the top of that lymphograph canopy, and it's going to be grazed if we don't get those animals off. So two very different kind of settings in terms of control of grass competition. So what happened? How did it turn out? So when we pulled the cattle off, just as soon as we got those little seedlings coming out of the ground, about 3 weeks later, this is what we were looking at, okay? I don't know about you, but I would say that that's a lot of grass competition. And I would say that those little seedlings have long since been buried in the understory of that grass. And then what we end up with when we come back with animals sometime later is just a handful of Aeschynomene plants and basically a lymphograss pasture. All right, what happened if we grazed that extra 3 weeks? This is what it looked like at the same date as this picture. I think you could say that that's a definite decrease in grass competition here. And this is what we ended up with. A significant stand of Aeschynomene for that animal to graze. All right, so that's addressing the first question. Can we reliably establish Aeschynomene? I'll give you a summary of those answers in just a minute, but let's finish addressing the few questions about this plan. Second question, can it naturally reseed? So, we're natural reseed, we need flowers, we need seed. So yes, it produces quite a bit of seed. So that's to our advantage. And you can see those seed here. The challenge is that this is happening in the fall of the year, and we may wish to actually be grazing Aeschynomene at that time of the year. But if we wish to reseed, for it to reseed, we're gonna have to pull the cattle off, because if they eat the flowers and if they eat the seed pods, there's not gonna be seed dropping for the next year. So we have to manage grazing in the fall, and in the subsequent spring, we need to manage it again in order for that plant to reseed. Challenging? Yeah. All right, we'll comment on that again in just a minute. But before we do, let's look at what effect does, if we get Aeschynomene, what effect does it have on animal performance? 3 years of data, steer average daily gain, these are yearling steers, grazing about a period of around 130 to 150 days during the summertime. What's our average daily gain? Lymphograph with the legume, that's Aeschynomene, yellow, versus lymphograph nitrogen fertilized. In some years, up to twice as much individual animal gain on a per day basis with the legume. So let's review. Can it be established? Yes. I think you give me an area of land, some cattle, I can establish Aeschynomene reliably. That question's been resolved in my mind. Can it naturally reseed such that we do not need to plant it every year? Yes, but it's challenging. Grazing management in the fall, grazing management in the spring. My observation has been that although we can accomplish that objective, it's generally beyond the level of interest or dedication of most producers. They simply don't need that much hassle. So that's a challenge if you want the Aeschynomene to come back every year. Does it increase animal performance? No doubt about it. All right, so that's one of our legumes. So let's talk about Rhizoma peanut. Rhizoma peanut is another warm season forage, warm season legume, but this one is a perennial, has been used to a greater extent for hay, but it absolutely totally can be grazed if you wish to. So again, we're going to start by looking at establishment, competing with the headgrass, how long does it live, and animal performance. I don't know how many times those of us represented in this room have said that Aeschynomene, or excuse me, the Rhizoma peanut is slow and hard to establish. I would probably be happy if you gave me $10 for every time that was said by someone who's in this room. I might not come back to work tomorrow. So before I go there, you're going to get lost in numbers. So let me introduce this. So in thinking about this a little bit, we set up some experiments where we looked at 10 planting dates a year in each of 3 years for peanut. That's 30 observations, 30 planting dates. And we planted over a 20-week period from March to July, every 2 weeks each year. Okay, so 10 dates each year, 3 years. And then we looked at what we had in terms of peanut at the end of that first growing season, recognizing that the conventional wisdom says that it takes 2 to 3 years to establish Rhizoma peanut, and it's hard. Okay, conventional wisdom. All right. So 2021, I'm going to just show you 2 years, 2021, 2022, planting dates are over here. There were 10 of them. I didn't think you wanted to look at a table with 10 planting date numbers in it. So I just give you 4. This is the first week, the 4th week, the 7th week, and the 10th or 10th planting date each year. What was the percent cover at the end of the growing season after having planted at those dates? Planted in March 21, by November 21, we're somewhere around 90%, 95% cover. A little less, around 80 when we planted in April. Down here around 70, you say, what happened there? Notice that we planted these in areas where we irrigated to average precipitation, or were totally rain-fed, no water, all right? What happened was in May of 2021, it was very, very dry, and it was also very, very dry in June. So we had basically a failure in that month. Go back to then planting in July. By the end of the growing season, we're somewhere 50 to 75% cover. Second year, very similar, somewhere around 90%. Here, going down to between 50 and 60% cover by the end of November. So what's that look like? 50% cover may not mean anything to you, but there on the left is basically what it means to me. All right, so plant in July, by November, that's what we've got. All right, on the right, 90% cover. We planted earlier, a little earlier in the season. That's what we've got by the end of the year. To me, and I've actually followed these plots, by the next spring, we're at 100%. One growing season, okay? Done it 3 years, 30 planting dates. That 50% on the other side is going to look pretty much like the one on the right by the next spring, all right? So I'll comment on a little more on that later. Does it compete well with the headgrass? I'm just going to again show you some pictures to illustrate this. We've used, and Dr. DeBay has used, strip planting of peanut as a way to kind of reduce the amount of planted area with the idea of saving some cost on the planting process. So this is existing headgrass pasture on either side with a tilled strip in the middle. We plant the rhizomes, and then down here in the bottom right is what we expect to see after probably 2 months or so after planting, okay? We're going to move north. Those pictures were taken at the beef unit in Gainesville. Now we're moving north to Marianna, and here's a picture of Dr. DeBay's strip planting situation where he's got peanuts, and and the grass. But what I really want to show you is this picture. And I give credit to Dr. Bay and his group for this picture as well. These are those original planted strips of peanut, but you notice the strips of Bahia grass are really narrow, or at least they seem to be. Why is that? Because peanut spreads aggressively, all right? And so over time, the peanut has basically lapped, and you can see there's a little bit of a yellow tint. That's the flower of the peanut. So the question then on the floor was, does peanut compete with Bahia grass? Absolutely. It will spread into existing Bahia grass. To me, that's the definition of competitive. All right. So it will do that. How long does it live? Well, I wasn't there at the time, but in the 1960s, at the USDA Subtropical Research Center, Brooksville, some peanut was planted. And Dr. Blunt tells me that it's still there 60 years later. Okay. In 1983, I actually was there. I'm dating myself here. But at the Beef Research Unit in Gainesville in 1983, I participated in planting activity with Florida grazed rhizoma peanut. One of my graduate students is in the room today, and last year and this year, he is doing an experiment using those pastures, and they are the original stands of Florida grazed rhizoma peanut. So, you know, I visited that stand very regularly every year in that 40-year period, and I can state categorically that was that planting, and it's still there. Last point, what about the impact on animal performance? Well, we have a couple of studies I'm going to highlight. In Gainesville, we did some work with yearling beef steers, 5 months grazing during the summer. Pasture that was 80 to 85% peanut. Those animals gained 2 pounds a day through the summer compared to 0.8 pounds a day on Bahia. And here in the center of this table, Dr. DeBay's group did work looking at average daily gain of that strip planted area that you just saw. And those animals with 32% peanut in the mixture gained 1.35 pounds per day compared to 0.7, 0.8 for Bahia grass. So does peanut have a positive impact on animal performance? No doubt. All right, so let's answer those questions. So what about establishment? So I make the argument that if we consistently use good planting material and control competition during the year of planting, establishment won't be slow. All right, some of you may wish to argue with me about that. I've observed it so many times that I feel comfortable. I think what we don't do often enough is that we're not aware of what is good planting material, and we don't do an adequate job of controlling competition, do those shoots in the first year when they emerge. Does it compete with Bahia grass? Absolutely. We don't need to worry about that one. How long does it live? I have no clue. I have no clue. Comparing the peanut pasture and me, my money's on the pasture. All right. I'll be gone, pasture will still be here. What is the impact on animal performance? It's big. All right, let's move on. And we're going to talk about some cool season legumes now. We'll talk about clovers and alfalfa. And you see there, alfalfa, this is North Florida Holsteins near Gainesville. We've got some red clover here and some crimson. And again, similar kinds of questions, establishment, productivity, and animal performance. So one of the issues with alfalfa within the context where I've interacted with it most is on a dairy farm. And in most of those cases, they are sod seeding alfalfa into existing Bermuda grass pastures or hayfields, Bermuda grass hayfields on a dairy situation. So within that context, we have to be concerned about grass competition. And so what do we need to think about? Well, some work we did at Gainesville, we looked at using a low rate of glyphosate, basically to try to put that Bermuda grass to sleep so that it's not competing with the alfalfa excessively. And on your right, you see, and it doesn't show up as very green there, but there is some green in the area where we did not apply the glyphosate. So that's in preparation for planting. And we also typically mow those areas short in the fall as the Bermuda grass is going dormant before we plant the alfalfa. So now we plant the alfalfa, and Those are the plots that we planted on the left. That's at North Florida Holsteins on the right. We definitely then do need to control that grass competition in the fall of the year when we plant. And something that I've observed, and this is observational, and I thought about generating the data, but I haven't had time to do it. One of the challenges that I've observed in establishing alfalfa and grasses is that the seedlings get to about the point here where they are at the tip of that yellow arrow, and they start to get a little yellowish looking, which says to me that the nitrogen fixation engine is not yet working real well. And what I would like to look at, but what I think is probably the case here, is that if we could come out there with about 20 pounds of N, that would be enough to get those seedlings out of that funk that they're in and get to a point where they're fixing adequate N to establish. How long will alfalfa be productive? Now, you may or may not be aware, but in Pennsylvania, alfalfa doesn't live forever. Okay. We get a good stand. We're looking at 5 years, something like that, and we're going to replant. Okay. Now, we're not there. We're not there for Florida yet. We're not pushing 5 years. Okay. What can we get? All right. So we did a little study where we looked at harvest frequency of alfalfa and Bermuda grass mixtures. And you can see that less frequent harvesting, 4 to 6 weeks, means that we keep the alfalfa around a little longer. By 18 months after planting, we're still somewhere between 30 and 50% of cover of alfalfa. Our dairy friends will sometimes want to put some nitrogen or dairy slurry on their Bermuda grass alfalfa mixture, particularly because during the summertime, they're concerned that when the alfalfa slows down, they want to make sure that they sustain yield. And so they put some nitrogen out there for the grass, all right? So we looked at what happens if you apply some nitrogen versus no nitrogen, in this case, 40 pounds of nitrogen per acre after harvest. Basically what we found, again, this was planted in November 2019, pictures taken on the 6th of May 2021. That's a dang good stand as far as I'm concerned, on basically 2 years, 2 production seasons in, compared to where we applied nitrogen, not doing so well. All right, let's then move on and talk about some clovers and mixtures with cool season grasses and animal performance. And the answer to this one is a little different. Okay. So this is Dr. DeBay's group's data, and there's 100 pounds of nitrogen applied on the rye oat nitrogen treatment, which is this one. And then we have a rye oat clover treatment. What's the effect on average daily gain? Really modest, slight advantage here toward inclusion of the clover. What we would point out, however, is that this number comes from pastures where there was 30 pounds of nitrogen applied in the fall to help jumpstart that grass component, whereas here, that number is associated with application of 100 pounds of N split in multiple applications throughout the cool season. Right, so let's answer our questions. Challenges to establish alfalfa in grasses. We need to worry about controlling grass competition. It's not as big a deal as when we're planting a warm season legume into a warm season grass, because grass is going to go dormant, but it's still got to be worried about it. And I think we might need some starter ends sometimes. How long will alfalfa be productive? I think 2 good years is highly achievable in Florida. If we're going to apply nitrogen or dairy slurry, that may not happen. What about animal performance? We don't get the bump that we see here by adding the legume when we're talking about cool season grasses, because they have much higher protein and digestibility than our warm season plants. But again, keep in mind that we are doing that without paying as much for nitrogen. Okay, let me give you a couple quick take homes and then we'll wrap this thing up. What about Aeschynomene? Relatively easy to establish the first time. Okay, I can give you a pretty easy recipe for that one, I think. Documented large impact on game. Requires careful management to naturally reseed, and many producers not interested in that level of management. So that's the good news, the bad news. I'm just giving you the news, okay? I think that's straight. Rhizoma peanut, competitive, extremely persistent. I think I'm pretty persistent, so, it outlives me. It's pretty persistent, right? Costly to establish, yeah, but okay, if you're going to be in this business for a while, how about if you amortize it over 40 years? What's it look like? It's still going to be there. If you establish it well, it will be there, all right? So point 3, Sollenberger's opinion, okay? Take it with a grain of salt. Slow establishment has been overstated and reflects a lack of understanding of the value of good quality sprigs and good competition control in your plant. Okay, people can disagree on that one. I'm happy to hear contrasting opinions. That's mine. Weeds, if we integrate peanut with grass, less of an issue. All right, alfalfa, clovers, starter nitrogen. We apply nitrogen to the mixture. We can boost total yield, but we'll reduce alfalfa stand life. Clover is not going to give as much of a boost to animal performance, but it is going to substitute for nitrogen and provide various services. Dr. DeBay asked me to look forward a little bit. I'm not very good at that. So that part of the talk's really short. Going to look at it from 2 perspectives. 1, focusing on important plant characteristics. 1, and then 2, economic societal issues. Beef cattle context. What I know about the beef cattle industry is that they prioritize persistence, long-term persistence, low cost, low risk, ease of management. Anything we do from a legume perspective that we want to apply to that group, it's got to hit those, it's got to check those boxes. If it doesn't, we're wasting our time trying to talk to them about it, okay? Dairy. Productivity and particularly quality move up. Quality especially moves up as being more important within the dairy context. They're willing to replant every few years if they can get the quality. So it's a different mindset. Ease of management, still important. Okay, so those are things that as we think about developing legumes, we need to keep in mind, I think, the needs of the people we're working with. All right, economic societal issues, cost of nitrogen fertilizer. I don't know where that's going, but that's clearly a big player in legumes. I mean, if you look historically, when is the interest spike in legumes? Whenever oil prices and nitrogen fertilizer prices are high. Level of societal concern about climate change mitigation. Okay, if South Florida gets worried about, going underwater, then there's greater interest in things like legumes that reduce the amount of greenhouse gas emissions. Does society value broader benefits of legumes enough to incentivize adoption? Those are questions I don't know the answer to, but they will affect the degree to which legumes are used in the future. Last few things for my colleagues who work in science. Here are a few observations for you. Biological complexity fascinates scientists, but complex management solutions are rarely implemented by producers. Okay, we biologists, we love complex things. It's great. I just stay up at night dreaming about it, thinking about it. But in terms of application, not so much. Producers are risk averse, otherwise they probably would not be in business. So we need to keep those things in mind as we develop technology. And good legume technology is a rare find for warm climates. Expect a challenging search. If you find it, be prepared to advocate for its adoption. Adoption won't happen quickly. That's what I've got. It's been a pleasure to talk with you all today.